Hello everyone, myself Dr. Sree Lakshmi, Assistant Professor in the Department of AIML at Institute of Aeronautical Engineering. In this section, I am going to discuss about iteration method, which is used to find out the root of the given polynomial. The iteration method is very useful when it becomes very tedious to find solution to cubic, biquadratic and transcendental equations. Bisection method is not used for finding out the complex roots. Like that, each and every method will have some limitations, disadvantages and then advantages. Here the iteration method is used as a fixed point in a repeated manner to compute the solution of the given equation. A fixed point is a point in the domain of the function g such that g of x is equal to x. And here an algorithm for iteration method, how you need to find out the root value for the given polynomial equation. Step 1. Choose the initial value x0 for the iterative method. Here we required x0 value and this x0 value will be taken from a and b values. One way to choose x0 is to find the values x is equal to a initially and x is equal to b, where a and b gives the function values, one negative value and one positive value. And step 2, express the given equation in the form of x is equal to g of x, such that modulus g of x dash should be less than 1 at x is equal to x0. This condition should be satisfied always. The derivative of the given function should be less than 1. If there is more than one possibility of g of x, choose the g of x which has the minimum value of g dash of x at x is equal to x0. This is the important condition. Step 3. By applying the successive approximation, xn is equal to g of xn minus 1. If f is continuous function, we get a sequence of xn which converges to a point which is the approximate solution of the given equation. So in this way, we will calculate the root of the given polynomial. And here the important facts which we need to remember is the form of x is equal to g of x can be chosen in many ways, but we choose g of x for which this should be satisfied. What it means? So suppose there is an equation x cube is equal to or x is equal to 3x. Now what is x means? In general we can take in many ways x cube by 3 is equal to x, or x is equal to 3x whole power 1 by 3. The facts we need to remember, the first point is the form of x is equal to g of x can be chosen in many ways. Here I chosen in two ways. One x value is x cube by 3 and the other value is x is equal to 3x whole power 1 by 3. But we choose g of x for which mod g dash of x less than 1 at x is equal to x0. So here what we should take? This should be less than 1. If you consider this, then the condition will fail. This condition will fail. If you take this, the condition will fail. If you take in this format, the condition will not fail. The condition will not fail because some value will be always less than. So choosing of the g of x is very important and that is based on this condition. Now lower the value of g of x, fewer the iterations are required to get the approximate solutions. The rate of convergence is more if the value of g of x is smaller. This method is useful for finding the real roots of the equation which is in the form of an infinite series. This method is very much useful when infinite series is given. Now with an example we will see the iteration method, how it will calculate the root of the polynomial. So I'm going to consider the equation f of x is equal to x cube minus 4x minus 9. And from this equation, I need to find out the roots initially. So I'm going to take f of 0, where it is minus 9. That is x is equal to 0, f of 0 is minus 9. X is equal to 1, f of 1 is equal to minus 12. F of 2 is equal to minus 9. F of 3 is equal to 6. So now I will choose A and B. A is equals to 2 and B is equal to 3. So now from this A is equal to 2, B is equal to 3. That is one negative value and one positive value we will got. And from this 2, we will find out x0 value. That is the root which is required for the iteration method. x0 is what? 2 plus 3 by 2. That is 2.5. So now I got x0 value. Now this is step 1. Now what is step 2? Now I will take the step 2 as the given function is g of x, where we need to consider x cube minus 4x minus 9. Now I will reorder this expression as x cube is equal to 4x plus 9, where x is equal to 4x plus 9 whole power 1 by 3. Or even you can consider x is equal to cube root of 4x plus 9. Whichever is comfort when we are doing for calculations, we can use that. So this is the value, x value, which satisfies the formula at x is equal to x0. Now for each and every value of x0, we will find out the root value. So for iteration method, the formula is xn plus 1 is equal to, now I am going to consider this as xn, whichever function is given that we need to use here. So first iteration n is equal to 0 I am going to consider. So x1 is equal to what we will have? x0. x0 in the sense 4x0 plus 9 whole power 1 by 3. As we take an x is equal to g of x. Here the g of x is, this is the function, and x0 value we will take. So how you will calculate this? 4 into x0 is how much? 2.5 plus 9 whole power 1 by 3. Or else we can consider cube root of 4x plus 9 also. Now what is the value for this? x1 is equal to 2.668. You can consider up to 2 decimals. So now this is x1. First iteration is done. Now for second iteration, x2 is equal to 4 into x1 plus 9 whole power 1 by 3. That is 4 into 2.668 plus 9 whole power 1 by 3. So this x2 value is approximately equal to how much? 2.707. So now x2 is 2.707. This is first iteration and this is second iteration. And now third iteration, that is x3 is equal to 4x2 plus 9 whole power 1 by 3. Where 4 into what is x2? Actually 2.707. So 2.707 plus 9 whole power 1 by 3. So this x3 is approximately equal to how much? 2.712. This is third iteration. And fourth iteration, x4 is equal to 4 into x cube plus 9 whole power 1 by 3, which is equal to 4 into 2.712 plus 9 whole power 1 by 3. So which is approximately equals to 2.712. So if you observe, x4 is same as x3. Since we consider only 3 decimals, we went with 4 iterations only. So now if you take this x5, fifth iteration, since the root value is same here, you will get 2.712 plus 9 whole power 1 by 3, which is approximately equals to 2.712. Now we can conclude that the root value of the given function is approximately 2.712. So in this way you will find out the root of the given polynomial function. So by using iteration method, we can calculate the root value easily when compared with the regular falsy method or bisection method. So this is about iteration method. We can stop as we need number of decimals. Here I am considering only 2 decimals. So we attain the root value at 5th iteration. The content is taken from SS Sastry. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.